Sean, you will learn to love C++. But before that, answer me. I want you guys to answer this. Without knowing the address of that memory location ABCD, can I print out what the elements are? Yes or no? Right? We can't, because we have no clue what that memory allocation is, right? So there is no way of printing out the array elements. But since we have returned from this function, so this particular memory allocation takes up 16 bytes. Now, once we return from this function, and we are not assigning this thing, but we did use new to assign this array. So this memory is still allocated in heap, right? Does this get removed? I want to know if you think that will this particular array get removed if I'm not using it. Exactly, Brian, you are correct, and everyone else is actually correct. So is Brian. Exactly. If I do not delete it, this memory is not removed by default, right? So this is what we call a memory leak, sort of what Chrome does when it takes up 14 gigatillion of GBs of memory, because it is not releasing the memory that it is currently using. So that is something, but that is what we call a memory leak. It is essentially allocating memory but not releasing the memory, and there is no way for me to access that particular memory location. Now, roundabout way, somebody talked about managed programming languages. So Parvez, you once asked long time back that whether these things are done automatically in C++ or MATLAB or Python. So when I have such a principle, such a programming language in C++, this memory is never going to be released. However, if we are using an interpreted language such as Python, Java, or MATLAB, which requires some background program to run every time, because we are running it as Java program name, Python program name, MATLAB program name, right? So we basically need a background program to run, and we cannot run this program directly on our system. So it has an interpreter running in the background that maintains a dictionary or a database of variables. So it also can maintain the set of variables that are not being used at all. In this particular scenario, this particular variable at this particular address ABCD is not being used at all. So Java, Python, and MATLAB would delete this particular memory location. But C++ will not, right? Yes, Parvez, you are correct. So the other way around, exactly. C++ wants you to delete or manage every memory location that you assign. Java, Python, and MATLAB would actually take care of those variables, and that is what we call when we say automatic garbage collection. Automatic garbage collection is essentially this particular background facility where if you do not use a particular memory location, those programming languages remove them for you. So that is a benefit for Python, Java, and MATLAB. But I see that I do have one person, I think Sean, who hates C++. So Eric, again, any programming language that uses garbage collection would have to spend extra time to maintain those variables and delete those. Do you agree? Even if it is automatically not interpreted and automatically executed, there is a part in that program that maintains those variables and deletes them when necessary. And that is now, in case of C#, it is inbuilt in your program. Do you understand the thing that I'm saying? Exactly, right. So this automated garbage collection is expensive in our graduate class sense, time consuming. We have been talking about big O stuff and all of those things. These removal of variables are quite time consuming. Since C++ does not care about these things, that is why Sean, That is why C++ is faster than any of those languages. Do you agree? Do you understand? Sure. That's what I mean. Sean, it basically depends upon, do you want your program to use as few processing units as possible? And are you going to be clever enough to remove all the required variables to get the as much juice, to extract as much juice as possible from your processor? So that is why we talk about assembly language programming and embedded programming. Yep, Parvez, you are right. Machine language. Yes. So that is why we use those sort of languages, right? Can I extract as much juice as possible from my processor? Or am I going to be a high level programming language and I'm just going to work on high level things and not bother about smaller details? Both of those things have merits in both of those cases. For example, I will not code a machine learning neural network algorithm in assembly. Like, come on, I'm not going to do that. However, if I'm going to write a program that runs on, I don't know, the train system or a bus ticket checking system, where every byte counts, in that scenario, I would rather write it in C++ rather than Python or some other language. Okay. So it depends upon the use case. Okay, so coming back to this weird thing that we had, and we have taken up a lot of time, and we are still on slide 2. Cool. Okay. I need to know why I got into this discussion. Give me 1 sec. I need to know why I got into this. Yes. So essentially, yes, as Brian is figures out, Python uses a managed data structure that is not the same as using linked lists, but internally, since Python is a managed programming language, internally it still uses C++ data structures to represent those things. It just has separate functions for those things, but internally Python is still using a linked list or an array data structure. Oh my god, I went from that to here. Okay, so Python lists are the same as C++ linked lists in terms of time complexity. Does everyone understand that? Yes, so in that scenario, I guess that is for it for today. We are again going to continue this next class, but I do want you guys to go through the slides and chapter 22 for the textbook. And as you know, I've already uploaded a reference book so that you guys can also look into that. I know that we have gotten into a bit more detail than we wanted to, but these are important things that you want to learn about. And that is the reason why whenever I talk about complexity in terms of time complexity or space complexity, we are going to look at it in terms of C++, because think about it like this, that every other language is sort of represented, sort of implemented on top of C++, right? So I mean, we have a Java interpreter, we have a Python interpreter, but what is that Java or Python interpreter written in? Right, it is written in C++. So Even your Windows programming language or your Linux obviously is written in C++. So we are only going to talk about space complexity, and we are going to talk about space complexity in more detail later. But we are only going to talk about uh, space complexity and time complexity in terms of the traditional data structures given to us by C++. Brian is, I think that the slides for, let's see, it is chapter 22 from the Corman book, and it is chapter 3 from the reference book. Yes. There, so Taha, there will not be a quiz on, so Taha and Brian, so there will not be a quiz on Tuesday because we did not cover anything of relevance today. We just discussed about these data structures and things like that. Potentially, we will have a quiz next Thursday. Corman, so Brian is, Corman is the best book, follow that. This is just a reference book, separate reference book. When in doubt, use the reference book, but always follow the Corman book. It should be, yes, chapter 22. It should be a goal to finish. So for all of you, it should be the goal for you to finish the entire Corman book while we finish up the semester. It will help you with your interviews, and it will help you with your C++, not C++, your algorithmic knowledge completely. Not the most, but completely. Okay, so I'll stop recording and I'll stop sharing.